Good morning, afternoon, and evening, everyone. Thanks for joining us for another Cassandra Lunch. We have a special lunch in store for you guys today. Our speaker this afternoon is going to be Obi. We're going to be going over migrating Cassandra data to YugaByteDB. Just a few housekeeping items. The co-organizers for this event, Raul and myself, we are looking for speakers and sponsors and also co-organizers. So if you're interested in growing the Cassandra community, getting different people together, please reach out. My email is listed below as well. And if you're interested in speaking at one of these lunches in the future, don't hesitate to reach out. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome and we expect respect to be given to all. Data Community DC is made up of a lot of different groups, generally surrounding data. You can find out more about these groups in the links listed below. What do we cover on Cassandra Lunch? We cover everything related to Cassandra, Spark, Kafka. If this is your first time joining our Cassandra Lunch, please introduce yourself in the chat, how you found out about our lunch, what you're hoping to learn from these lunches, and how you're working with Cassandra in whatever capacity. Rules for this event, as we mentioned before, please be polite and courteous to everyone on the call, on the lunch. If you have a question, please ask it. We are fostering a community here, so please don't hesitate to ask your questions. And obviously, we want you to share what you know with us. Here at Anant, we design, build, and manage global real-time and data analytics platforms surrounding Cassandra, Spark, and Kafka. So if it's your first time here, you'll soon find out Cassandra is our bread and butter. We'd like to thank our program sponsors, our organizational sponsors listed below. And then very quickly, if you have any jobs, meetups, hackathons, conferences, classes, or any other announcements, please leave them in the chat along with a slight description and a link as well. And we are hiring here at Anant, full-time and part-time positions. If you're interested or if you're looking for more information, please visit our careers website linked below or reach out to me directly. I'd like to point you guys to a special event we have coming up in February, the Scylla DB Summit. That's going to be online February 15th and the 16th. Please register online now. We also have our weekly launches coming up on Mondays and Thursdays, our data engineering lunch, and obviously our Cassandra lunch. So please check those out and join us when you can. Our Cassandra lunch videos are on our channel, all our previous lunches. So if you missed the lunch or if you're looking for more information on a particular topic, do take some time to subscribe to our channel and also go through our Cassandra lunch videos. We do have a playlist for that, so it's easy for you to find and go through and check out our videos. And then finally, Cassandra.Link, we want to point you to the #1 resource for all things Cassandra related, just Cassandra.Link. I'll be leaving a link for that in the chat as well. Although it is Cassandra.Link, it's pretty easy. And then finally, our latest edition of our Cassandra runbook did release this week. This edition is focused on token imbalance, updating JVM, heap size, and node sync. This runbook is free. If you haven't downloaded your copy, please do so as soon as you can. If you're not familiar with our runbooks, they are available for a limited time. And yeah, so please just download your edition before the next edition comes out. And with that, I will hand it over to our speaker for this afternoon. Over to you, Obi.
All right, thanks, Akwe. Give me 1 second to start sharing. Hey, I'm Obioma Anomnachi. I'm an engineer here at Anant. Our topic today, is migrating Cassandra data to YugaByteDB. I believe this is going to be one of the first times we've talked about Yugabyte specifically at a Cassandra lunch, but it's well within the sort of range of topics that we generally like to cover. I'm going to talk specifically about solutions to use Spark to move data from open source Cassandra into YugaByteDB. I generally prefer to take questions during breaks in the presentation, but of course I can't actually see YouTube chat right now. So I will be relying on Akwe to let me know when there are questions. We'll be taking a pause in between different sections of the talk to go over those questions. So before we actually get started here, those sections are going to be, we're going to talk about Yugabyte generally. We're going to talk about migration to Yugabyte and the different ways that that can go. And then we're going to talk about the specific solution based on Scylla Migrator and the sort of steps that I had to take to get that to transfer data. So starting out, YugaByteDB is an open source distributed SQL database. Usually when we're talking here at Cassandra Lunch, we're talking about specifically NoSQL databases. But Yugabyte, of course, has a relational layer in a sort of Postgres-like interface. But still, YugaByteDB shares many advantages with NoSQL databases like Cassandra. Horizontal scalability and native replication, as well as geo distribution. But like it says here on the trade-offs column, non-relational databases, NoSQL databases generally lack things like ACID consistency. Sometimes they lack the ability to create indices, and they lack the ability to do things that you can do with a relational data model like joins. But Yugabyte does have access to those things, including joins and actual ACID transactions, not the sort of workarounds that you generally see in NoSQL databases. So in Cassandra, that would be things like lightweight transactions, etc. Yes. So talking about migration to Yugabyte. So if you just look it up, you're going to find this thing, YugaByteDB Voyager. This is a tool that helps you move data from legacy relational databases into Yugabyte. And it's very good for that. Another way you could potentially move data from a relational database into Yugabyte is to export that data to CSV using the /copy command in Postgres, export it to a CSV, import it via that CSV file from the Yugabyte side inside their Postgres layer as well. So that will be use YPSQL, use the copy command, pull that data in from a CSV file. Obviously, there are size limits to that sort of thing, but YugaByteDB Voyager is a tool for when you've exceeded those. And then moving data from Cassandra, there is actually a blog post on the Yugabyte blog that talks about using CQL copy or DS bulk to replicate this same sort of CSV-based method of moving data. So you can use CQL copy in both CQLSH and YCQLSH, the Yugabyte version, to export and import small CSV files. And then you can use DS bulk on the Cassandra side and the Yugabyte Cassandra loader on the Yugabyte side via its CQL interface to move CSV files that are gigabyte or gigabyte or terabyte sizes. But a lot of systems actually have data bigger than that. And obviously you can, put that down into sections and do this via the CSV method. There's no solution like Yugabyte Voyager for this solution. And so that's sort of the topic of today's talk, where I tried to use the Scylla Migrator, which is meant for moving data between Cassandra and Scylla databases, to move data into Yugabyte using its CQL layer. All right, so starting at the very beginning, you go and get the base Scylla Migrator, and you build it and you try to use it on Yugabyte. So we're going to see this more explicitly during the demo, but I set up a little Docker lab where there is an open source Cassandra, a single node cluster, a single node Yugabyte cluster, and then a Spark master and Spark worker. And I set that up in a little Docker environment with the Docker Compose, so I have a little lab to work with. But if you try to move data using the standard Scylla Migrator, so if you just pull it down from the repo and build it, obviously you don't run into any build issues there because it's meant to work out of the box for Cassandra and Scylla databases. But when you try to run it, you get errors like the one mentioned here. Can't find reference user type JSONB. And I believe this is because the way that the Spark Cassandra connector, at least the version that this uses for Spark 2.4, has inside it like an explicit list of all of these types. And because Yugabyte actually has an extra type, JSONB, for explicitly representing JSON data, and normal Cassandra, so Cassandra and Scylla both lack that type, the Spark Cassandra connector doesn't have any way to represent it. So even if your table doesn't have any JSONB types in it, when it's trying to do that communication from Yugabyte, there's no type for it in the Spark Cassandra connector code. And potentially this might even go deeper and be coming from the Cassandra driver, the Cassandra driver. Whereas I've confirmed that there's no, inside the Scylla migrator code, there's no explicit references to the JSONB type anywhere. So this fails. You get everything's fine during build, but when you try to run it, the section that it gets to in Scylla migrator. Okay, so the way that Scylla migrator works is first it loads in the config file and builds up objects for your source and your target database. It gets the schema for those and modifies it so that it can transfer TTL in write time if those options are enabled. So it sets up, so it takes your original schema for your source database, it sets that up to extract the TTL in write time for all of the columns that have that. And then it sets up your source database for what it's actually going to try and write to bring them in line with any sort of renames and decisions about TTL and write time in there. And then it starts writing the data. So this section here that we're looking at, if you could scroll up a little, and I don't know how readable this all is, but what's listed out at the very top of the screen under runtime failure is the source. So this is from the Cassandra side, the source schema for this table listed out with the TTL and write time extracted. But then it tries to do, it says unexpected error while refreshing schema during initialization, keeping previous version, but that's just a warning. It talks about not being able to find JSONB. But then there's an error while it tries to write the data frame. So this is when it's trying to write anything to the target, it fails, and you get the same message, can't find reference user type JSONB. So the potential solution that I came up with for this is, what if I took out the Scylla fork of Spark Cassandra connector and replaced it with Yugabyte's version? So ran into a little bit of issues there. So in Scylla migrator, the code base, in their build.sh file, there is a command git submodule update. Because the Spark Cassandra connector and then DynamoDB and Kinesis files are in Git submodules. They're in different repos, but are getting pulled into this repo. Basically, this command, the git submodule update, if you've made any changes to them, it replaces them with that code again. So if this is left in, no changes that you make to the Spark Cassandra connector are going to stick when you try to build. So you have to comment out that line. And then the copy command, the Yugabyte version of Spark Cassandra connector is actually the file system of it is formatted a little bit differently. So in this case, the build target is going to be in a folder called Spark Cassandra connector target, et cetera, down to the jar file. But what the base Scylla migrator is looking for is a different folder, Spark Cassandra connector /connector/target, et cetera, down to the jar file. So you have to make sure that you're getting the actual jar file that's being built. And then one thing also to make sure, if you're doing this in the same repo as you were before, so if at any point you've built these submodules, what build.sh does is it copies them into a folder called lib in the Scylla Migrator directory. And so you need to make sure that there's not two versions of the Spark Cassandra connector jar in that library, because they'll conflict with each other essentially. So basically, to get the Spark Cassandra connector Yugabyte version, you just delete the folder Spark Cassandra connector inside your Scylla Migrator folder, and you clone the Yugabyte repo in that folder. So the main branch there is 2.4-YB. And then when you do this, the Yugabyte version of Spark Cassandra connector actually needs some updates. The place where they're going to get their Spark packages, the address there has changed. So we'll look at the specifics, I think, in another slide or during the demo or something. But inside Spark Cassandra connector project plugins.sbt, there's a reference to where they want to go and get the Spark packages, but that site is down. It's moved to a different location. So you need to replace it with the actual new address. And then what happens here when you try to build is there are issues regarding some subcomponents of the Spark Cassandra connector. So the way that Scylla Migrator wants to use Spark Cassandra connector, it's looking for specific types. It's looking for specific setups for methods and things like that. And these aren't necessarily compatible. So it's probably hard to see here. But essentially what we're looking at is stuff like the source table def isn't being loaded in properly. I think partially because of the Cassandra options. I don't know if this is something that the Yugabyte version of Spark Cassandra connector allows, but it's essentially a way to allow Spark to not load in things that aren't there. But I believe in this case, it results in treating this table definition as if it doesn't exist. So it's complaining about all of these variables not being part of the class nothing. So rather than getting out the Cassandra option, which you can take these, so you can get, say, clustering columns, or you can get partition key columns from it, it instead treats this as a nothing object, which of course you can't get any of those things from. And then the consistency level, it's actually pulling that instead of from the Spark driver core, where it would generally pull them, it's pulling them from somewhere else. And so they're incompatible in that way as well. And then there are also methods that it wants to use, like save to Cassandra, which it feeds in the arguments in a particular way. The Yugabyte Spark Cassandra connector complains about that because its save to Cassandra method takes a different number of arguments or something. So basically, in this case, the build fails. So you move on to another solution. In this case, move to the Spark 3.1 version of the Scylla Migrator. So Spark 3.1 version of Scylla Migrator, Spark 3.1 is going to be compatible with higher versions of the Spark Cassandra connector, which will hopefully act differently. And then hopefully it will be able to build and also be able to run. So you do the same method as before for replacing the Spark Cassandra connector, except that instead of getting the 2.4-YB branch, you're getting the 3.1 Yugabyte branch of the UI Spark Cassandra connector. And then you have to update your Spark packages address the same way as before, because it still has the old one in there. And then, so I don't know if this is actually still necessary, because it looked like there had been some updates in late last year to this 3.1 branch of the Scylla Migrator. But in previous experience working with the Scylla Migrator, only the Cassandra sections of the 3.1 had worked. And so if you would try to build then, you would get issues relating to the DynamoDB and the Kinesis sections. So those data sources and syncs, readers, and writers all needed to be removed from the repo in that case. And that is the starting point for this repo. And then, of course, you run into build issues because the Scylla migrator for Spark 3.1 and the Yugabyte version 3.1, there are these issues. First, where it wants to load in a bunch of its dependencies from all these different places, and they conflict with each other. So instead, what I've set it to do specifically, it's module info.class from 2 or 3 different dependencies inside of the build SBT. So we've added, it's always module info.class. So we've used the merge strategy for those to discard. So any new versions of that, rather than trying to be deduplicated or using the specific one, will just be thrown out. And then that gets you a new error, new build issue once that's fixed, which is not found type token range accumulator. So the token range accumulator is something that Scylla Migrator uses in its save points functionality so that it can resume from partway through any failed runs, but it's not in this version of Spark Cassandra connector. So you end up with issues there. And then issues that I saw in the process of this, but was not able to replicate for this presentation. So in an attempt to use one of the 2.4 versions, I got this issue related to system.peers_v2, that it's looking for that table, presumably in Yugabyte where it doesn't exist. Because looking into the system table, it's there in Cassandra, but it's not there in Yugabyte. And obviously you can't really mess around with this key space to fix that. And then there was another issue during runtime for one of these other versions where there was an error relating to the system partitions folder, which, looking again in the system key space, does not exist in open source Cassandra, but does exist in Yugabyte's system key space. And then ran into a couple of runtime errors before the source schema could be properly loaded. So things like that same JSON-B error, but before it actually managed to work with Yugabyte. And I think potentially in that case, I had the source and target mixed up. So, but that still signals issues in loading data from a Yugabyte cluster, using this to migrate data from Yugabyte to open source Cassandra, which of course is not actually the topic of this lunch, but is potentially something that would need to be fixed if Scylla Migrator really wanted to support Yugabyte as one of its options. Because of course you can use Scylla Migrator to move data from Cassandra to Scylla, but also from Scylla to Cassandra if you had any reason to want to do that. Okay, so in the end, something that actually built and actually worked. And there's a repo for this that I will be linking to later. This is what we're going to see in the demo in just a second. So it's the Scylla Migrator Spark 3.1.1 version with Kinesis and DynamoDB references stripped out, both in the submodules. So the submodules for Kinesis and DynamoDB have been removed, and then also references to them in the code. So like the DynamoDB reader and the DynamoDB writer have both been removed, et cetera, but also anywhere that, so the way that Scylla Migrator uses its data sources is that there's case statements that do different things depending on which data source you're actually talking about. And all of the DynamoDB options for those have been removed as well. And then anything that uses the token range accumulator type or object have also been removed. This destroys the save points functionality. So it talks in the code, the comments are still there. It talks about making save points, But looking in those files, there's no set of token ranges to skip in them any longer. So trying to use those to restart the migration will just restart it from the beginning. And then, of course, we're using the Yugabyte Spark Cassandra connector 3.1 branch. And then with this same fix for the Spark packages having moved to a different site. All right, we're going to move to the demo now. Akwi, if there are any questions, now is the time. Okay. So this environment, looking at it, has been up for about 50 minutes. But as you can see, first image is Spark Worker, Spark Master, Yugabyte, in this case, Yugabyte 2.8 Docker container. And this is actually something that I also had issues with at the very beginning. Using the Yugabyte latest tag actually gave me issues. There was some program used for clock synchronization that wouldn't properly install, but switching to one of the older versions got it to run just fine. And then using Cassandra latest, so we're actually going to end up with a version of Cassandra 4.0 to migrate data from. And then if we want to, oh yeah, I never had the opportunity to show off what the actual new site was. So Spark Cassandra connector, project, plugins. A question, how long did it take you to find the solution? So this was definitely several hours of work. So even once I had figured out that maybe I could substitute in the Yugabyte version for the Spark Cassandra connector, basically just experiencing these errors, figuring out what to do next. Maybe I can update the Spark version, and then realizing that, you know, there are some dumb mistakes in here, like that time that I said that I had mixed up the source and target. So it was trying to migrate from Yugabyte to Cassandra, even though there was no data in Yugabyte. And issues like the Yugabyte version Docker container thing that I mentioned just now, and things like Spark packages here. You know, it's definitely not like an easy fix. Just even in order to get something that will migrate data. But luckily all that work is done. So that's like a starting point now for anyone working on this going forward. But yeah, so as you can see, the change inside of the Spark Cassandra connector, the Yugabyte version, is to update this resolver, Spark packages at, and then it gives an address. So the proper address is now repos.spark packages. But previously those were all hosted somewhere else. So this just allows it to be downloaded properly. And then, so this is, well, it's a redo of the build, so you don't see every message that would have shown up. But as you can see in the build, there's still some errors, some warnings around. Yeah. And you don't see those warnings if you're just building the standard Spark connector. So they're potentially something to upgrade if this is a solution that is going to be workable for enterprise people who hate it when they see any error messages. All right. So starting out for the migration, what we're going to do is put our test data on the Docker containers. Actually, is this already done? Because I bought these containers up and down several times, so I may need to drop the data from them right now. Okay, table does not exist in Yugabyte. Table does not exist in Cassandra either. Okay. So step one, set up the schemas and the data. And we can take a look into these files if necessary, but we're going to look at the schema in CQLSH in just a second, and then we'll take a brief look at some of the data as well. So I don't think there's any need to look into these files. It's just CQL files with the information in them. So describe and test data by date. So in YCQLSH, running this command. So the Scylla migrator does not transfer the schema for you, which is why we're setting up the schema on both sides in advance. You would need some additional tooling for that to automate it, or you would have to do it manually. And just to show you that we have the same schema on the Cassandra side, they have different options, all this stuff down here, but the actual schema of the table is the same, and even the cluster. So next thing we do is we upload some actual data into the Cassandra side. And this might take a few minutes. So if there are questions in the chat, this is also probably a good time. Probably actually should have cut down on the number of rows in this file. We'll see when we run the count statement on Cassandra that there are 50,000 rows in this file, which in terms of data that you can put in Cassandra isn't that much. But when you're running all the Docker containers on your single machine, and it's not that great of a machine anyway, can still end up taking a little while. All right. So we can see in Yugabyte, the table is there, but there is no data. And we can see the schema as well. And then if we look on the Cassandra side, if we run our count command, $50,000 rows in Cassandra. And then if we modify this to be looking at Cassandra, we can see what data we're talking about. So if you're paying really close attention earlier to the schema, you would have seen that basically none of this data has a write time or TTL. That option is checked in the config. Essentially, we are transferring write times and TTLs. But because the primary key of this table consists of every column except metric val, only metric val has a write time and TTL to transfer. So moving on to the actual running of the command. So we're running it on the container SparkMaster. SparkMaster has volume set up, which is how basically how we can get away without copying config.yaml and the jar file up there. It's using volumes to pull that in already. But we're running Spark submit. The class that we're entering it on, com.ScyllaDB.migrator.migrator. There's also validator, which is used to basically tell you if there are any differences between the two tables, used to check your work. Because this is all in Docker Compose, we can use the simplified like aliases for the host names. So the Spark master IP is actually Spark master because that's what the container is named in the Docker Compose. We give it the port. We give it Spark driver host. It's the same thing, setting up a driver on a specific machine. And then we pass in the config file. So the way that Scylla Migrator takes config files is you actually pass in config for the file path rather than passing it in as a Spark file or anything like that. Not even an argument, just a configuration variable. And then we're specifying the jar. Jar is Scylla Migrator assembly 001. And we hit run. Okay, so starting out, runs a bunch of this boilerplate stuff. We have the app running here. And then we're gonna have to go through this manually. So application starts here. You can see it's running. First thing, load in config from your configuration file. So we get a migrator config object. The source is a Cassandra type source. The host name is Cassandra, port, all these options, key space, table, other options. That's things like split size and stuff that determine how fast this migration can take place depending on how many resources you have, and as well as whether write times and TTLs are being transferred. And then the target definition, which is a Scylla type, host name is Yugabyte, et cetera, same options, et cetera. And then we're passing in a save points directory, even though the save points that are being saved there are going to be pretty useless. And then information about how you would run validation with this config file if you were entering in the validator main class. And then you can see we're still getting some warnings about stuff. Unexpected error while refreshing partition metadata. We got similar warnings previously, but instead of going into an error, it says keeping previous version, et cetera, and then it tells you about the query. It's talking about the system partitions table. And I believe because this doesn't exist in the source database, but it does exist in Yugabyte, there's some stuff going on here. We get our table definition for the source. It's basically the schema just printed out with all of the types and stuff like that. And it tells us about the original schema that it gets from the Spark Cassandra connector. And then it takes that, generates all the columns that we're going to pull out. You can limit this through different methods. if you only want to migrate some columns from your tables. And then it pulls TTLs in write time. So the way it does this, you get a TTL in write time column added to the data frame for every column in your table that has a TTL in write time. But when further on, we look at the writing schema. So this is for writing to Scylla. It tells you the what it's going to use to write. There's only one TTL value and one write time value here. This does not mean that all of your output rows will have the same TTL and write time. It's just each individual. You can still, this is tests that we've done previously. But if you look in your results, if you have tables with, if you have rows with columns that have different TTLs and write times, those will be reflected in the end in the finished migration. And then it goes through the renames process. So after it modifies your source data frame to be in this format as well. And it talks again about trying to refresh a partition metadata, not really being able to. Tells you about partitions that are going to be transferred, and then starts writing. And then it also tells you, because you have the option to rename things, rename columns in your target database. If you set any of those options, it tells you what your actual schema is going to be. And so now that we're here, we can run a count on the Yugabyte side again, see that all 50,000 rows have been transferred. And then we can even see that that data is actually transferred properly. So as I mentioned, this isn't like perfect. There's still some issues with save points. There's still warnings everywhere. But it does in fact transfer data from open source Cassandra to Yugabyte. I see a question here. Thanks for the work you put into making this work. What do you know now that you really wish you knew when you started? So I don't know. I had a lot of trouble with the SBT portions. And so just having more knowledge of that when I started. So the edits that I had to make to the Spark packages stuff and the conflicts in the build SBT for the Scylla Migrator once the Spark Cassandra connector shifted around. All of those things I wish I had known more about before I had to wait in and try and fix them. I think that process would have been a lot quicker. But in the general sense, I mean, there's not really like the starting point of this process is what if I just pulled it down and tried to get it to work? And then the steps that were moved from there are, in my opinion, at least all pretty logical things. So I don't know if there's like foreknowledge that really would have helped. Just, I think looking into stuff like this, you want to have debugging skill, you want to be pretty good at Googling, et cetera, et cetera. What is the amount of time you estimate it takes to transfer 50,000 rows? So I feel like that was only like 2-3 minutes tops. If we look at the comments, these are all within the same minute, right? 1737 at the top of these messages, 1737 at the last message you printed out here. But that's not the actual. So after this is when it actually started moving data. But we can't really see that. I wonder if we have access to the Spark UI. this is something that you could actually see. Yeah, not quite hooked up to the Docker correctly. And I don't think it's being broadcast on localhost. Yeah, no. So I'd have to mess around with the Docker. But if you look in the Spark Master UI, you can actually see the application and see how long it actually took to run. But that 50,000 rows was only a couple of minutes to transfer. And, you know, there was like a minute of overhead before it started transferring. Yeah, so I don't think the time is going to be too onerous, especially for small amounts of data that need to be transferred. All right, so potential improvements to make on the tool from here. So all those warnings about system key space stuff is presumably because Yugabyte, and I don't know why I wrote Scylla there. Anyway, Cassandra and Yugabyte, their system key spaces aren't fully aligned. So like I mentioned previously, if you look in the system key space in Cassandra, there are all these V2 tables, so peers V2, et cetera, et cetera. And Yugabyte doesn't have this. That might be a Cassandra 4.0 thing, but it also might have been transferred in earlier, and Yugabyte just chose not to replicate it. But them being out of alignment is causing these warnings to show up. You probably will want to, support the save point functionality. And that will require a Spark Cassandra connector version that is both compatible with how all of those variables are being used within the Spark, within the Scylla migrator, and then also supports the token range accumulator objects. The Yugabyte Spark Cassandra connectors all need to have their project plugins SVT updated with the actual Spark packages location. And then there's the usage of all those things like the consistency level and Cassandra options that could theoretically bring the 2.4 version of Yugabyte Spark Cassandra connector in line with the Scylla fork. And then improvements to use this as a sort of more general migration tooling. You could use Terraform and Ansible to set up and provision your target database and your Spark clusters for moving that data around. And then you can use Airflow for migration and scheduling. Since we're already at the point with a working Scylla migrator that you can use a Spark submit command, that means that Airflow Spark submit operator will work perfectly well for scheduling and automating the running of this migrator. And we've talked about that previously in some Airflow and Spark and Cassandra lunches that we've had, so I don't really feel the need to go into details here. But maybe in the future, if I have this system actually set up, I can show it off on a separate lunch. Okay, so the resources section for this is just basically my changes to these libraries. So the Spark Cassandra connector is forked from the Yugabyte version. The version U1 is still 3.1/YB, and it's got the Spark packages fix in there. Only on the 3.1 version, I hadn't updated any of the other branches, so you can't actually use this to mess around with 2.4 version without making the Spark packages plugins update. And then currently these are on my personal GitHub, but they will be being put on the Anant GitHub as soon as time permits. And then in the Anant Migrator repo, what you have is the version of Scylla Migrator with the Kinesis and DynamoDB stuff removed, with all of the save point stuff removed, with the changes made to build SVT, et cetera, et cetera. So theoretically, the version that you download, it even has the sub module connected to this specific branch of the Spark Cassandra connector. So I don't know if it's downloading the right branch from that actually. Something to check. But basically the idea is that if you go to this Migrator repo, you should be able to pull it down and have it built, and just be able to theoretically use it. All right, more time for questions now as we sort of log off.
So if you do have any questions for Obi, please go ahead and leave them in the chat. While we wait for any questions and close out, I just want to remind everyone that our latest runbook is out. Please visit our website for more information on that, and also our events page. We have a special Scylla DB Summit coming up mid-February, which is online, so you could attend it the same way you're attending our lunches. So we'd like you guys to check that out, and we encourage you to register now. Yeah, it looks like we don't have any other questions in the chat. So Obi, I'd like to thank you for another excellent lunch this afternoon. I'd like to thank our friends over at Yugabyte as well. And yeah, I think with that, we'll go ahead and close out. Thank you, everybody, for joining. We'll see you same time, same place next week. Take care, everyone. Right. Something.